As you've probably seen in a few videos, we use a fair bit of a compound called dimethyl oxalate in our reactions. It's a really useful and versatile organic reagent. We wanted to see if we could use the methyl equivalent, dimethyl oxalate, in some of the reactions instead. So today we're going to have a go at preparing this. Here's our starting material. 64 grams of anhydrous oxalic acid. It's a fine white powder and you can make it by heating oxalic acid dihydrate carefully in an oven at about 130 degrees for a few hours. And we're going to react this with methanol. So here's 75 ml of dry methanol. The reaction we're doing is an esterification, where carboxylic acid reacts with an alcohol to form an ester. In the case of oxalic acid, there are two carboxylic acid groups, and so it will react with 2 mole equivalents of methanol, forming a diester product. Let's add the methanol to the oxalic acid. And now we'll add a large magnetic stir bar. And let's get stirring strongly. We'll just wash the sides of the beaker with a little bit of methanol. Okay, as you probably know, esterification normally requires an acid catalyst. So here we've got 25 ml of concentrated sulfuric acid. This seems like a lot, but we're going to try this out to see if it enables a quick and easy preparation. The mixture is stirring really strongly now, and it's cooled down a bit as the oxalic acid goes into solution. So we'll carefully add the acid. Well, it's definitely warmed right up now. And you can see some methanol vapor coming off. And within a few more minutes of stirring, the oxalic acid completely dissolves in the mixture, forming a clear solution. Okay, now we're going to gently heat the mixture up to boiling point. We're not sure how much heat this is going to need, but we'll go steady and find out. Use ventilation here because you don't want to breathe in toxic methanol vapors. If you're feeling adventurous, you could also simply try microwaving the mixture, but be very careful because it could boil over very easily. We're using some plastic wrap to help keep the vapor and the heat in the beaker. Getting quite hot now, so let's keep an eye on the temperature. We're now getting close to 90 degrees C. And soon there's some bubbles forming in the stirred mixture, as you can see. And we're there. We've screwed up the lighting, but the temperature on the thermometer is about 100 degrees C at this point. So we take off the beaker and allow to cool slowly. We also remove the stir bar. There's a very faint yellow-brown color to the mixture as it cools. We're now going to chill this in the fridge overnight for 12 hours to allow the dimethyl oxalate to crystallize out. It's a fairly slow process to complete. And here we are 12 hours later. What appears to be an almost solid mass of white ice-like crystals in the beaker. On breaking up a bit, it converts into a slush of crystals. So let's filter these off. The filtration is quick, but drying takes a while, and we left the mixture on the filter until no more drops came off. This took about 30 minutes. Here's what we've got. A mass of crystals on the left, and the slightly yellow-colored filtrate on the right. Here's the crystals. Very suspiciously 65 grams of crude product. Exactly the quantity of oxalic acid we started with. But we'll do some tests later, so you'll have to trust us. It's not oxalic acid. Here's the filtrate. We wanted to see if we could recover any more product from this, so we did an experiment. Whilst oxalic acid is pretty soluble in water, dimethyl oxalate isn't. So we added about 30 ml of water to the filtrate and then chilled this down in the fridge for a few more hours to see what would happen. Here's the result. Again, it looks like we've got a slush of crystals forming in here. So let's filter again and see what we get. Unfortunately, the fine crystals shrank as the water was sucked out, and the end result was only a small amount of product after drying. Okay, so back to our main product. It's still very slightly damp, probably from the sulfuric acid, which isn't volatile. So we'll need to recrystallize these. To do this, we'll use hot methanol. Here's 60 ml and we'll see how we get on with it. Let's get it warm on the hot plate, and then add some to our crude product crystals in the beaker. With a bit of heating, it dissolves quite rapidly in about 50 ml of methanol. It could also be melting and mixing with the solvent as well. Okay, we'll take this off the heat now and allow to cool. We then left it in the fridge for a couple of hours in order to crystallize. And here we go. So let's filter. We let the pump run and dry for 45 minutes in order to get all the liquid and methanol off. And here we go. Our recrystallized product. 55 grams of dry white crystals of dimethyl oxalate. Unlike diethyl oxalate, which is a liquid at room temperature, the dimethyl ester is a crystalline solid, which seems unusual but it's true. 55 grams is a 64% yield on our starting oxalic acid, which isn't bad considering that we didn't reflux the mixture at all. Combined with about another 5 grams of product we obtained from the filtrate, this goes up to a 70% yield in total. Okay, well, let's do a few simple tests on this. It's easy to prove it's not oxalic acid. A few crystals placed in a beaker of water don't dissolve at all. We don't have a proper melting point apparatus, but let's try to do a rudimentary test. The thermometer is a bit exposed to air and only the bottom is touching the beaker, so we'll probably get the underestimate of the actual melting point. But let's try. We're going to heat very slowly and see what happens. Temperature is very slowly increasing. We get our first sign of the material starting to melt at about 45 degrees C on the thermometer. And it then melts pretty quickly. And now there are no more solids remaining at all in the bottom of the beaker. The temperature on our thermometer at this point is around 51 degrees C. So our melting point range is 45 to 51 degrees C. The literature says around 54 degrees C. So it's actually not too bad. Not that far off. As we said before, this is useful stuff and we'll be coming back to it in some future videos and also trying it out in some of the preparations we've done in the past with the ethyl esters. So stay tuned and see what we get up to. Thanks for watching.